Apollo 11, man's first landing on the moon. There was no objective more important to science than the collection and return of samples from the lunar surface. For never before had we the opportunity to examine extraterrestrial material from a positively known location and context. Fortunately, at the site of the landing, in the southwestern part of the Sea of Tranquility, there was a considerable variety of lunar material, much of it debris from nearby impact craters. First, contingency samples were chosen and collected rapidly. Later, as operations continued smoothly, samples were chosen and collected more deliberately. Within 5 days after the samples were picked up from the lunar surface, where they had lain for millions of years, they were delivered to the Lunar Receiving Laboratory at the Manned Spacecraft Center, Houston, Texas. The importance of the event was underscored by the presence of top NASA officials. The containers were opened inside special vacuum chambers and nitrogen-filled cabinets where decontamination took place. Samples were examined, described, photographed, and weighed. They were then prepared for preliminary physical and chemical analysis. Meanwhile, a number of Earth organisms were exposed to lunar material to assure that there were no pathological hazards. Among the organisms were plants, such as conifer seedlings, and tobacco tissue cultures. Invertebrate animals, such as insects, shrimp, and the almost microscopic paramecia, and vertebrate animals, such as the Japanese quail, and germ-free mice. In an intensive series of biological tests over a number of weeks, there were no indications of pathological effects among any of the organisms. As preliminary investigations continued under the direction of scientists from academic institutions and government agencies, it became apparent that 4 general types of lunar materials had been collected. There was the lunar soil itself, composed of a variety of glasses mixed with crystal and angular rock fragments. There were fine-grained crystalline volcanic rocks, characterized by minerals whose crystalline faces reflected in light, and by bubbles, or vesicles, which formed when the rocks were molten. There were somewhat coarser-grained volcanic rocks, marked by irregular cavities or vugs, which formed when the rocks were partly molten. Common to both types of volcanic rocks were the whitish mineral, which is known as plagioclase feldspar, the darker one, which is clinopyroxene, and the blackish one, which is ilmenite, or an iron titanium oxide. Finally, there were the breccias, comprising fragments of volcanic rock in a matrix of lunar soil. These were formed by impact hardening. Like all the rocks, the breccias are pockmarked by pits formed by the impact of particles traveling at high velocity. In preliminary studies of the lunar samples in the Lunar Receiving Laboratory, there were several significant findings. For instance, all the rocks are similar chemically, pointing to a family relationship. Although the components were known, the proportions are strange, suggesting either formative processes unknown to us on Earth or an unfamiliar bulk composition for the Moon. The soil and breccias contain large amounts of noble gases, that is, gases which do not combine readily in chemical reactions. Most of the gases were derived from the solar wind. In most of the rocks, there is evidence of shock. There is evidence of both lava flows and impact. Strangely, the breccias are far more magnetic than the volcanic rocks, the very material from which they were derived. There was no evidence that surface water had ever been present at the landing site. Neither was there evidence of any biological material. Perhaps the most interesting discovery was that the volcanic rocks are at least 3 billion years of age. dating back as far, perhaps further, than the oldest rocks ever discovered on Earth. It would seem that if the lunar samples of the Apollo 11 landing do not themselves take us back to the origin of the moon, then certainly rocks from other regions will. While the preliminary investigations produced new discoveries, they also led to a more intelligent distribution of the lunar material to the international team of 142 scientists who will conduct detailed investigations. Among those present when the first samples were distributed were Dr. Daniel Anderson, Lunar Receiving Laboratory Curator, Manned Spacecraft Center, and Dr. Paul Gast, Columbia University, Dr. Stuart Agrell, Cambridge University in England, Dr. Kurt Frederickson, Smithsonian Institution, Dr. Dieter Heyman, Rice University. These scientists are studying in detail such things as formative processes, physical properties, bulk chemistry, and the relative abundances of elements in primordial matter. Even as their work proceeded through the initial stages, Apollo 12 returned more lunar rocks to Earth. The 12 samples, while handled in much the same way as the 11 samples, received much more detailed photographic coverage and analysis. The specimens caused a number of questions to be formulated. For instance, why are some rocks coated with glass where they lay exposed above the lunar surface? How long have they lain there, before coating and after coating, to have had their glass surfaces peppered and shattered by micrometeoroid-type impacts? What processes have formed the rocks? What relationship do the processes that formed this tiny spherule of lunar dust bear to the processes that form the moon and the solar system? What is the structure and evolution of the lunar surface? Are we looking at a continually evolving surface or a primitive terrain coated with dust? How does this compare with the history of Earth? As we examine the surface of the Earth, we can read the events of the last million years with relative clarity of detail. As we move further back in time, the detail blurs until the signs before about 3.5 billion years ago are totally obliterated. The reading of the moon's history seems to be inverted. It is speculated from evidence at hand that for the first 500 million years, there was as much activity on the moon as there has been for the last 4 billion years, as though it were a world frozen in time. Generally, the rocks collected by the Apollo 12 crew at Oceanus Procelorum are somewhat younger than those collected by Apollo 11 at the Sea of Tranquility, about 3.3 billion years versus about 3.6 billion. Then there is Rock 13, age dated at about 4.6 billion years. Its origins perhaps dating back to the formation of the solar system. We are now seeing the moon at many levels of detail, and what we are seeing is extending our scientific and philosophical base in a major way. A new chapter in science is being written, a chapter it is felt that will have at least as much impact on our methods of thinking as Darwin's theory of natural selection.